Make sure you read and reread this problem and make sure you understand the function given to you, the S of t. S of t is the stone's height in feet above the water t seconds after the stone is thrown. So we want to know the maximum height of the stone. To find the maximum height, basically, let's find the vertex. So let's find the vertex of this quadratic function. Remember the x value, in this case the t value, we find that by negative b over 2a, so that's negative b is 32, over 2 times a is negative 16, so the t value is 1, and then to find the corresponding s of t value, we find s of 1, and s of 1 is negative 16 times 1 squared, plus 32 times 1, plus 256, and that is 272. Now, what does this vertex represent? In other words, this graph has a vertex with coordinates 1, 272. Notice, if we graph, this parabola faces or opens downward, so the vertex represents the top or highest point, and that's how we find then the maximum. What is the maximum stone's height? It is 272 feet. It is this y value or s of t value, and this t value gives us when it occurs. So it occurs at 1 second, but the maximum height is 272 feet. Now let's find the time it takes the stone to hit the water. To find the time it takes the stone to hit the water, we want to know when the stone's height is 0. And the stone's height is 0 when this is 0. So I'm solving 0 equals negative 16t squared plus 32t plus 256. Now there is a common factor of negative 16 throughout, so I'll divide every single term by negative 16. So that's 0 equal t squared. This divided by negative 16, that's minus 2t. And this divided by negative 16, that's minus 16. I'll let you solve by using the quadratic formula. If you do, you'll find that t is 2 plus or minus square root of 68 all over 2. And if you simplify this, that is 1 plus or minus square root of 17. Now remember, we're looking for a time. If you find 1 minus square root of 17, that's a negative number, so we reject that proposed solution to our application, and t then is exactly 1 plus square root of 17 seconds. That is approximately 5 and 12 hundredths seconds. That's our time.